All right. Writer, same stuff. We got a side by side here. We got writer on the left. We'll look at example first. So writer. So still we're looking at scenarios why we need a writer. So let's say we have 3 functions. Easy enough. Just doing some additions and multiplications and I don't know how to call this, but divide by 3. Add by 1, multiply by 2. Oh, sorry, I changed the name here. Multiply by 2 and divide by 3. Okay, so it's very easy to compose them like this. It works, no problem. But when we want to log stuff for every single function, this is not the way we do it. This line. All right, console log adding 1 to A and add 1A. It's not how we do it in functional programming because this thing is side effects. Right? We're talking about pure function here, so this is not pure. It's impure function. So we don't do this. Instead, as in the radar, we go through examples to say, is that a pattern? We can abstract to build on top of it. So instead of log it straight away, we return the value that together with the operation return value. So the logging message will be inside the array as a return value. The first element will be, as usual, what we call, this function, we call it. And we have the return value here. And the second element for that array will be the log message. Again, the concept is exactly the same as radar, as in, database connection needs to pass in the end. The mechanism or the effects for logging is separate concern. But the message is tightly coupled with your function. Right? So we don't care how you log it. You're writing to disk, you're writing to console, you're writing to Amazon, CloudWatch, whatever you want. But we produce the message here. Same for multiply. There's a typo here. Sorry, I'm going to change this. By 2 with log. So again, same. We have value here, and we have the logging message. Value here for the divide by 3 and message. Okay, same question. How do we compose the above? Apparently, we compose like this, right? Because the type doesn't match. Yeah. So option 1, let's try to figure out how do we compose. And again, we explore by generating the type signature here in mind. We have integer, looking at this function, right? Where is this function? This function. Okay, it takes the integer, well, it takes a number, let's say it's integer. And what does it return? Array, and what's the first? It's an integer, and then it's a string. Okay, maybe we'll use number here. And maybe better, yeah. So we have divide by 3 there. Okay, so that means this function will receive the number and string, right? Okay. So we deconstruct it like this. This is the value. This is the logging message. And what we do is first we call the next function with add 1 with log, with the a, which is if I pass 1 here, I'll be getting 2. Right? So after this line, I'll be getting number, string, again, right? For calling this, sorry, for calling this. Yeah? Then what I do is I call adjust. Adjust this array at element index 1. That means adjusting this string. by concatenating the last log message. Yeah? So that means I got number string as well, because I just concatenate another string on top of it. It still doesn't change the type signature. Yeah. All right. So same thing happens here. Right. It's just calling divide by 3 now. Exactly the same concept. Let's run this thing. This is option 1. Sorry. Let me just comment out all these things. Yeah. Here is the writer example. Okay, because let me just do this. Because I put 2 string here, it was an array, like the opposite is an array. So you will say, actually, that's option 1 is that basically, right? And I have that's the final value, 1 plus 2 divided by 3, right, is 1. And the second element is that line break, that line break, that. Those 3 message is from here. Something added by 1, something multiplied by 2, and something divided by 3. That is the input for every single function. The input for first multiplication is 1, for add is 2, for divide is 3. That's the input for all these 3 functions. So apparently you can make a utility function of this, right? That's easy enough, and then just do this. But we call this in functional programming a writer, monad, which is a functor, which is applictive. Okay, so let me present option 2, which is using the writer monad. Before I do that, there's one important thing to note. The log message. The log message, the type is a string. A string, in an abstract sense, is a monoid. Monoid. Okay. Let me just increase my monoid. Okay. So string is a monoid because 2 things. One is it has a
identity.
Yeah, sort of. We call it empty value. Empty value is empty string. We also have what else? This concat, yes, has this method on it. That means the type signature for this method is string to string to string, right? I'm writing Haskell syntax, but it takes a string, takes another string, produces a string. Array is this makes it a monoid. Array is a monoid. What's the empty value there?
Empty array.
Empty array. It has a concat on it, which is array. That's I need to write it. Natural number. Is natural number starting from 0 or 1? 1. Okay. Yeah. Natural number. Is a monoid. What's the empty value for that monoid?
One.
1. Yeah.
1.
What's the binary operation which takes a natural number, another natural number, produces another natural number?
1.
What's that function on natural number? Is it add?
Multiple.
Is multiply, right?
Yeah, multiple.
the law for monoid is the empty value multiply or form a product with the same type, right? The natural number, any natural number is any natural number. Okay? String here, empty string, concat with any empty string, any string will be that any string itself. Right? Okay. So you need to satisfy this law to be a monoid as well. Yeah. By doing this,
Shouldn't be.
is that monoid
Oh.
with those two things?
No.
But it's for add. Add would be alright. For multiple
Okay.
is.
So let me just address this.
But if the
Is this still monoid with those two things?
yeah, if empty is 1.
Empty is 1, and multiply is
0 still 0.
is still 0.
Yeah.
So with these two things is still, right? It's still monoid.
Mm.
Okay.
Yeah.
It is also monoid, you say 0 and a plus, right?
Plus, yeah, add.
Okay. So that means you can make things monoid looking at it to satisfy this law, and you have a binary operation and the empty value. So it's not uncommon that you're looking at a set of things, you're making monoid into different monoid like this. So here, why are we talking about monoid? Because when you're looking at, let me just reduce the size of it. When you're looking at this string, right, it doesn't need to be string actually, because I call concat here. Is to form a monoid, you need a concat on it, right? I only call concatenate. I have no constraint to say it is a string. I'm actually saying that it should be a monoid.
Yes.
We're starting from empty string, right? And building up stuff. That is whatever this thing is. So I could be say, if I have array here, like this, it still works. Yeah? Like 3 of them all arrays. It should still work. That's one thing to note. That means the construct I'm building to handle this kind of pattern needs to be aware what kind of type I pass in, which needs to be a monoid.
Yes.
Yeah. Okay. So here, I'm using array, not string anymore. I put a function on array to make it a monoid.
Yes.
So after these 3 lines, array is officially a monoid. And then I say this writer is the library, right? The writer class. I give array as dependency to say use this monoid to accumulate the log. Okay, and then with that, I'm getting the writer again, which is now this writer is aware of what kind of monoid it contains. So when it concatenates things, it will concatenate on array. Okay. So to make the previous 3 functions to use writer, here is the 3 counterparts. Well, again, sorry, got typos again. Multiply by 2. So multiply by 2 with writer is to say, putting the value you have input into the writer. It's like a radar, like array, right? The earth method. After you put inside, I have an instance of writer now. The type has been changed from integer to writer contains integer. Okay, and the writer object has the instance for writer has a tell method on it. What it does is to say, give me a value. I will put inside the monoid you tell me. That's all it does. Whatever this is, it will be put into the monoid. Okay. And map again. Why we need this is because, let me write a type signature. Here we have writer and the, let's say, because the monoid is array, right? That's the monoid. And the log message is string. The value encapsulated is integer. Got it? Yeah? Here, sorry, string, it's actually this. According to Fantasyland, this method is implemented like this. It has a null there. I know I said that there won't be any null and undefined in the code base for functional programming, but this null you will never use it, actually. Right. In functional, like Haskell, this kind of language, it is an empty tuple. It presents no value, basically. But here, JavaScript, you use null. But you will never use it, I promise. That means you lose the value, right? After tell, this string will be put inside this array. But you lose the value it encapsulated. Yeah. Now, how do you get it back? You say, I map it. The map will receive null as input. That means this n here will be null, but you will never use it because here we say I'll put this a back inside to run multiply by 2. So this is, if a is 1, then this is 2. So after this line, the integer will be back. If a is 1, then this integer will be 2. Because we have map, right? The map is mapping on this position. So whatever this function returns will be on this position. It will be integer because this thing returns integer. Similar stuff here. We're just using @1. The log message is different. Similar will be here. Different function call, different message. Here's the compose K. When you examine, when you examine the type signature for these 3 functions, they all are this type form, right? That means this is the container, this is the value, right? So you're looking at a Kleisli arrow again, right? So a plain value, a functor, well, a monad, and a plain value. All those 3 functions, 1, 2, 3, are of this type signature. So what I can do is compose K. That's equal to, if I write it out, is equal to this. Right? So we use compose K for convenience. Again, with writer into run it. This time I don't pass anything because you already have all your message, right? So let's have a look. Hopefully it runs. It gives me a tuple. The first position is the value in the end. This is the previous, well, this is the option 1, right? This is option 2. And the message will be accumulated inside the array. That's the second position of tuple. Yeah. Might have a problem with this. Let me have a look. After you run it, if you do .1, that's the value. 1, yeah. And if you do ._2, it will be the array of strings, yeah. Yeah. Okay. I think I need to do this. Because it's concat, not append. Yeah. Yeah. Because JavaScript concat on array, it takes array and the value inside array. It works the same way. You know, like these are the same, right? So concat 1, it will be 1, 1. But if you do this, it'll be 1, 1 as well. Yeah. So the mistake I made here is just to put string. Sorry, to put string inside. It should be array of string. Yeah. Okay. Let me pull this over and look at the implementation for writer. First, you saw the tuple, right? The tuple in the console, like this. Where is it? Like this. That's because the implementation actually uses this thing. Tuple 2. Here you say, I think this is a good example to say I have 2 constructors for this type. One is called _1, one is called _2. So to, you know, make it concrete example here, tuple 2, 1, 2, t equals that, t _1 equals to 1, t dot _2 2. Yeah, good enough. Okay. All right. So at the beginning, we say we need to make writer aware what kind of dependency of monoid we need for accumulating logs. That's why we have this m here as an input to generate a writer. Inside, we actually define a writer, starting to do that. Again, encapsulate the run method is what you saw here. Run here. It's applicative, so it has this auth. It puts the value directly onto the writer. Remember, writer takes the run, which is a function. It actually returns, when you run it, it returns a tuple. To put a value directly into a writer, that means the value is at the first position for the tuple. So when you run it, writer of 1 dot run dot _1 will equals to 1. Okay. That means 2 will equals to this thing. M empty. What's M empty? Here. It's an empty array in our example. All right. Okay. Then we have this tau function. Yeah. Let's write this out. Okay. Now let's go through the example here. Here the type signature is that, but if you do dot run here, it will give you a tuple, A at the first position, right? And the empty array at second position. Yeah, okay. But we don't run it. Instead we tell. What does tell do? It gives you another writer, so it gives you the same type back. And well, writer takes a function. Right? What does the function do? Like radar around this. So what does this dot run mean is accumulate all the log message before me. So I'm ready to take another one. And it generated a tuple, which the first position is now. When you tell a writer to write a log, you lose the value. It encapsulates it. Instead, you have this log message, the new log message appended, well, concatenated. So that means after this line, if you run it, you will have a tuple. The first position will be now. The second position is multiplied by 2. So like if you pass 1 here, it will be 1 multiplied by 2. Yeah, okay. But we don't run it. What we do, we map it. What does map do? Again, run everything. If I call run it, I will run everything. But the result underscore 1 will be passed to f because that's the value it encapsulates. And the 2 doesn't change. So the log message doesn't change. Right? I run every single computation I have so far. All the log has been concatenated. And that is result dot underscore 2. That doesn't change when I map it, because mapping is on the first position. What's that result dot underscore 1 here? It will be now. Right? It will be now here. But here we don't use that now. We say always return this value. Always return, if I pass 1 as A here, it will be 2. Always return 2. So it will be a tuple of 2 and all the logs so far. Yeah? Okay. Same for this function, same for this function. And here is the same deal, right? Integer return the writer string, string and integer. And I'll just use compose K here. Finally, I run it. It will give me this kind of structure, tuple 1 and 2, and it will give me the result and then accumulate that message in the end. Yeah. And then we can touch on the chain. Same as radar, we need to reduce one level of writer here, right? Is by running multiple times. Again, same stuff. So that is writer. Yeah. Question? I'll come later. It's fine. Yeah. So we take a break. We'll go to stay afterwards, or possibly next time.